of quirky thing because you have two separate IP protocols, instances just for TCP and UDP, and if you wanted to have some variations between TCP, you would have many more instances. So that's probably not the best solution. So if we try composition instead, this is very close to the design you will find in the paper from 1995, which I mentioned. In this case, you dispatch from the hardware to something that is called, or you introduce something which is called a mux, which is basically the name giver for the TCP IP stack that I'm talking about. And a mux is taking input on one side and giving output to, depending on some criteria, to one of many channels on the other side. And so if on layer 1 we have a mux, but right now we only have one outgoing link, so that's the Ethernet protocol. Above that we have another mux for layer 2, the network layer, and from there we decide whether to pass it to the ARP object or to the IP object. And the IP again passes it on to the third layer and decides, is it ICMP, is it UDP, is it TCP? And when we are at TCP, and I'm just going to show this part here, we have a port mux, which is just a different kind of mux, which decides, well, is it port 8000 or is it port 22? And depending on this, passes it on to a connection object. And the connection object takes care of passing on all the information and passing around the information between web server and our TCP IP stack, or secure shell server and our TCP IP stack. And all those connections do have state. Those states are object too. I will go further into why that is later on. And well, that's ninja style. Okay, if we simplify the design, and actually I took out the mux out of muxtcp because I don't think it's needed. You have it like this. You have the Ethernet protocol talking to IP, IP talking to TCP, and the Ethernet protocol, and so on. Maybe if you start here thinking a little bit, you might come to the conclusion that IP actually also needs to talk to ARP, and because MAC and IP address are not completely unrelated by any means. And also here you see maybe on top of UDP you later want to have DNS. So you have this whole stack of protocols, and you might want to construct this protocol stack using a graphical user interface or whatever, but generally there is some dependency. Even if you would want to construct it using a graphical user interface, there will still be some interdependency between protocols, especially if you want to write hacking tools, because everything we are doing influences everything else. So the hybrid approach, I don't have because it's really chaotic, is just accepting that in the real world things are chaotic. And so all the protocols can talk to all the protocols. And we use the singleton pattern for that, which is basically just saying we have global variables through various means so that protocols can find each other and communicate with each other. And protocols communicate in any way they want, and they pass around objects saying what they want to do. It's not strictly necessary to do that, but sometimes I support both. direct packet building and requests to build packets, and command objects. Packets that are incoming are processed by the protocol chain. There's not much chaos there, though you can add diversion, so you can say, oh, now I'm entering a mode where I want to do some attack, and then things are not passed on to TCP, but some rogue protocol which does other things. And this is another diversion packets that you want to send. You don't pass down the whole layer structure till you get to the driver, and then it is sent. But the packets are sent by the layer generating them. They are merely asking all the other protocols to contribute in providing information to construct the packet and then make it ready for sending, and recording various state changes that happen by sending this packet. Another packet that is really, really helpful for maintaining the flexibility we need when we write a stack like this is the strategy pattern, which basically decouples the algorithm that we apply to state changes and within states from the actual protocol. So it's saying that the state in TCP listen, and all the logic that is associated with listening on a TCP socket is its own object. And when we make a transition from this state to a different one, it changes something in the protocol. It says it sets it to a different object. But the state, all this logic, it doesn't store data. It's just logic, which means we can easily add a new state, for example, for TCP traceroute, which isn't like we have listen, soon sent, soon received, fin wait one. We have all those TCP states implemented as objects, and we can add a new one like TCP traceroute, make a transition there, let it do its stuff, send packets with increasing time to live, and later on switch back to TCP established after fixing up all the information in the protocol, and continue as nothing would have happened. Yeah. So what doesn't work yet, I don't have IP fragmentation implemented yet. I had some experiments with that in a previous version based on inheritance, but that's not in it right now. Then most advanced IP and TCP options don't work yet. I don't have window sizes, I don't have all that fancy stuff yet, but I want to implement it. Then I don't have any ICMP handling right now, I didn't care. Things like simultaneous open or simultaneous close are absolutely not supported right now. I have no means to test them, they are really rare. DNS is not in there, which I hope to have really soon, or I think DNS is really important because you don't want to send out DNS requests from your main IP when everything else you are doing is coming from your own TCP IP stack. And well, ARP kind of works. I'm still not decided yet. I've played a little bit with it. Basically, it's really simple, but I re-implement it so often, so I don't really know what's the current status when I made the slides. So, yeah, so here you see I have basic ARP and I have full ARP, whatever. Then what's definitely working is the channel architecture, the channel protocol architecture, the conduits, for routing through packets and dispatching packets based on protocols, based on port numbers, based on IP addresses, abstracting that, avoiding having a class for each of those decision-making, decoupling all this decision-making from the protocols that you want to link together. Then I have semi-complete UDP support because it's really easy, though I don't have ICMP handling or message passing, which is another of those things where the protocols are really intertwined that can't be easily separated. Then I have all the basic TCP state transition for both listeners and Active Connect running without any problems. and I have rough twisted protocol integration. So what that means is I have a complete web server running, written in Python, running in the same process, in the same thread on the TCP IP stack. I have a complete secure shell server running on my own TCP IP stack, where I do all my app handling, where I do everything, where I do all the state transitions. You can connect there, you can log in, you can give your password, you can do connection forwarding, whatever. It's all written in Python and in the same server. It's not written by me. I specifically designed the stack so I can reuse Python code that's already there. Yep. I will make another attempt of actually demoing this. I mean, there's not much to see, but I hope you can see it. So. They call it test-driven development, so my main program is test. So let's see if this works. Oh, well. Okay, so what's my IP address? I didn't completely configure it because of the problems I had with my display, but I should be able to get it to work. Okay, so here we have it. It's running, and there's some weird debug messages, and here it registers a connection. It sees an IP packet. Here you have a state transition from listen to SYN received, and then a transition from SYN received to established. Connection is established here, some more debug info, and what I have here, I think, is the web server. Yep. So I have a web server running on there right now. If I'm lucky, I might get to my web browser without the screen going away. I have set up my web browser with an external proxy. So I should be able to go to this IP address. Which was it again? On port 8000. Oh, well. I need to set up the secure shell tunnel first. Yeah, the DNS seems to have problems here right now. I noticed some problems before, so I need to switch to a different DNS server. Yep, so here I have a directory listing. There are a few twisted integration quirks which don't work yet, so I can't open a file, but I can open directories right now. But that's really just a very minor problem. Should be able to fix it in half an hour or so.